Hey, this is the solutions for the extra problems I posted / created for the conjugates and algebra limits video. So out of these 5 problems, I'm just going to start with the first one and work my way down. Alright, so we have the limit as theta goes to pi of sine theta cotangent theta. I use theta here because it's a common variable for rotational stuff, okay? And if you continue with calculus, you're going to definitely be seeing it, and physics too. Alright. So something I have not yet said in the videos is that whenever you see trig, your goal should be to get it in terms of sines and cosines, right? So let's do that. We know tangent of theta is sine theta over cosine theta. Cotangent is 1 over tangent, which is to say cosine theta over sine theta. And then this becomes, because these signs are going to cancel out, the limit theta goes to pi of cosine theta, which is just -1, because if you look at the unit circle, it's going to be all the way over here on the left, on the very left end. Okay, that's the first one done. Not too bad. We got this. Let's do the second one. The limit as x goes to 8. The square root of x minus 4 minus 2 over x minus 8. Okay, let's plug it in. We get square root of 8 minus 4. 8 minus 4 is 4. Square root of 4 is 2. So 2 minus 2 is 0. 8 minus 8 is 0. So that does become 0 over 0. Conjugate time, right? We get square root x minus 4 minus 2. So the original limit times the conjugate. Minus 4 plus 2. Don't forget your limit. I almost did. Right? Let's use the algebra we have to simplify. We get x minus 4 over x minus 8 square root x minus 4 plus 2. English. Well, the top becomes x minus 8, so that can cancel out with the bottom. So we'll have the limit x goes to 8, 1 over square root x minus 4 plus 2. Well, square root of 8 minus 4 is square root of 4, which is 2, plus 2. This equals 1/4. Lovely. All right. So now let's do the third one. This third one will be over here in orange. We'll have the limit x goes to 3 of x cubed minus 2x squared minus 1 over 3x minus 2. All right, let's just plug it in and see what happens. 3 times 3 times 3, which is 3 cubed, is 9 times 3, which is 27, minus 2 times 9, minus 1 over 3 times 3, 9, minus 2, 7. Okay, so this is 18 minus 1, which is going to be negative 19. So you get 27 minus 19 over 7. I don't think this is going to simplify, but it'll be a nice fraction at least. We have 27 minus 19, right? I believe this becomes 8/7. Yep. So this limit, there's nothing special about it. You just plug it in, do your math right, you get 8/7. Wonderful. Cool. Okay, now let's do blue. We have the limit as x goes to 1 of x squared minus 1 over x to the 4th minus 1. If we plug this in, we are going to get 0 over 0. So we have to simplify. Now, you are probably thinking, let's simplify the top and the bottom. Wouldn't get you the wrong answer, just be more work. You want to simplify just the bottom because it's the bigger power, right? Of x squared minus 1 over this is still a difference of squares, which is the conjugate like algebra shortcut we learned. So this becomes x squared minus 1 times x squared plus 1, right? So then we get the limit x goes to 1, well these are going to cancel out, of 1 over x squared plus 1. If you plug in 1 to this, you'll get 2. Or sorry, 1 over 2. Oopsies. Arithmetic is hard, it's okay. Alright, and now, last but not least, we'll do green, right? Over here, we have the limit as x goes to 1 of x squared plus 1 over x to the 4th minus 1, right? So, again, same simplification on the bottom. This term and this term cancel out, so that we then get the limit x goes to 1 of 1 over x squared plus 1, sorry, minus 1, right? Let's just plug it in. We get 1 over 1 minus 1. We get 1 over 0, which is an indeterminate. Unfortunately, you are just going to have to leave it at that. So this limit does not exist. And to help with this, I'm going to display the graph of it, and you'll see that it's asymptotic, which just means it doesn't really exist there, but it gets really, really, really close to infinity. All right, so thank you for watching, and I'll see you in the next one. Also, if you could let me know in the comments which of these colors like looks best, looks worse, because I don't really see it on cameras, I see it differently. So to me, they all look fine. If one of them looks bad on camera, one of them looks better, please let me know. I'll try to use that one more or less respectively. So yes, thank you again for watching, and let me know about the colors.